You're live.
Okay, very good. Well, welcome everybody. We sure appreciate all of you for joining in. It's a privilege to have Ken Hamilton with us today. Ken's joining us from his office in Logan, Utah. I got to know Ken, maybe 3 or 4 years ago, and he really blessed my life because he taught me about that soil is more than just dirt. I really had no idea the depth of the soil life, and I didn't even begin to understand the biology that goes on in the soil. And so he got me started on a compost tea program on our ranch here in northeastern Nevada, which were high elevation, generally pretty low production, and we just run on some irrigated meadows and we graze those meadows. And so what appealed to me about Ken's approach was that it was very economical. It was biological. It's environmentally friendly. It's non-toxic. I personally feel like anything that should go in the soil can go in me, right? So the compost tea that I brew, not that I drink it, but I could. And I think that anything that is harmful to soil life is going to be eventually harmful to what ingests it, the livestock, the people. And so I appreciate that Ken has paid the price to become an expert in his field about the biological process. He's an excellent teacher also. And so during this presentation, I'm going to monitor the chat box. Again, for those of you who are joining in, if you have a question, just type it in the chat box and I will interject those questions during the presentation. We'll probably have a question and answer at the end also. So again, welcome, and we turn it over to Ken.
Thank you, Jared. We're happy to share some of the things that we've learned in agriculture. And when we begin working with farms, I find that the most important thing is that we have a correct understanding of how things work and why they work. This isn't going to be a product sales seminar. This is on the intelligence that drives the fundamental life forms of everything that lives. And so we want to examine that and make sure that as we manage or we steward this intelligence, that we're approaching it from the right place, the right understanding. And what we often see is that we are encountering more disease. We're encountering additional weed pressures. We're looking at staggering losses in nutrition. And so many of the agricultural companies that support or supply products to agricultural processes, we're not approaching or managing this intelligence right. So it's paramount that the farms that we work with understand what life is and how each section of life, whether it's an element, whether it's a microbe, whether it's any form of livestock, and ultimately up to nutrition, is put together by our Creator. And what we see is those specific laws generate success and they generate nutrition. When we violate those specific laws that govern intelligence, we are going to have problems. And we see this with crop disease. We see this with nutrition loss that transfers from the soil into plants, into livestock, into the human chain. And so it's all a connected system like Jared was speaking about earlier. So with that, let's start with the introduction to life.
Try the writer.
Mankind has not woven the web of life. We are but one thread within it. Whatever we do to the web, we do to ourselves. All things are bound together, all things connected. Farmers, ranchers, crop producers are partners with nature. God set up the plan and he defines the rules. If we follow his laws, those laws will help us. If we break his laws, we are on our own. Abraham Lincoln made a statement, "My concern is not whether God is on our side. My greatest concern is to be on God's side, for God is always right." So as we look to the creation of this world, in the very first book in Genesis, God said, "I created heavens and earth." At that point, he describes the earth was without form, it was void, and there was darkness upon the face of the deep. And the Spirit of God moved upon the face of the waters. God said, "Let there be light." Now, we sometimes casually think that this is the daylight that we have opposite of night. This is not. Light is this divine intelligence that God, our Heavenly Father, and his Son, Jesus Christ, put into every single element and every type of living organism on this earth. And so you think about that incredible engineering feat of intelligence. We have a myriad of different plants, and we don't have to teach them how to be the plant that they are. We have an endless spectrum of soil microorganisms, from bacteria to fungi to actinomyces to protozoa to nematode to micro and macro orthopods. We do not teach any of these organisms how to do their job. They are all divinely programmed with an intelligence that is the full purpose of why they are here. And so they're able to function and know what they're supposed to do. We don't teach our poultry, we don't teach our livestock how to be that type of living organism. That intelligence comes in them. And so if we begin to understand the nature of this incredible divine intelligence, we hopefully will approach it more as a steward than as a dictator. When we look at the process of creation, day one, there was a division of the light and the dark. Day two, there was a division of the waters from above and beneath. Day three, there was land and sea, waters divided. Also the creation of vegetation, all forms of vegetation. Day four, this is the lights that rule the day and the lights that rule the night. Day five, we see the bringing forth of life in the air and the life on the sea. Day six is life on land. These are the mammals. And furthermore, this is when man was put upon the earth. We are instructed which light proceedeth forth from the presence of God to feel the immensity of space. The light which is in all things, which giveth life to all things, which is the law by which all things are governed, even the power of God who sitteth upon his throne, who is in the bosom of eternity, who is in the midst of all things. And again, verily I say unto you, he hath given a law unto all things, by which they move in their season, in their times, and their courses are fixed, even the courses of heaven and earth, which comprehendeth the earth and all the planets. There are no accidents in nature. Everything happens for a reason. And that's why there are no shortcuts into doing things that are right. In the first chapter of Genesis, the Lord commanded in the process of creation 10 different references where all types of life were to reproduce after his kind. There are 2 additional references where it's noted whose seed was in itself, and God saw that this was good. In dominion, at the very last part of the first book of Genesis, God gives stewardship and responsibility, but not control. Like there's a difference between leaders and dictators. The most important aspect of dominion is self-control. And we are here as stewards. We are not the originators of these laws. We are not the designers of these laws. God has allowed us for a time to work with this intelligence that he has created. And I'm going to make a note right here that I think agriculture, whether it's food production, livestock production, is the best occupation that one can actually be involved in to see what God does. Here's a little conversation between God and a scientist. Hey, we scientists have figured out how to make life from dirt, just as described in that book of yours, Genesis. Oh, yeah? Yep. God says, show me. Scientist, no problem. Scientist starts to gather dirt. Just as he was about to start working with it, he's interrupted. Hold on. Stop, said God. What? God said, what are you doing? I'm gathering some dirt to generate life, just as described in your book. God said, get your own dirt. This is where we separate and we don't have that intelligence to put things together. We are merely stewards. We are not the creators of this intelligence. When you look at this, we are instructed that by the sweat of our face, we will eat the bread that we produce. We are brought forth out of the ground. We are dust, and to dust we shall return. Everything on this planet, everything is made up of elements. These are the basic inanimate building blocks of all life. Microbes use and combine elements to form and contribute to higher life structures. So this is what we're going to talk about. The divine design of elements are to build, used as building blocks for all forms of life. Microorganisms are initial builders as well. All higher life forms, insects, plants, animals, and humans, all of us depend upon elements and microbes. Natural design produces natural results. They're consistent, they're repeatable, they're predictable. Everything after its own kind. When we look at this, let's take just a minute and examine one tiny part of this divine creation, this divine intelligence, because everything is put together in a very specific way, and everything is governed by very specific laws. And so what we want to talk about here is the divine intelligence within us. In our DNA, the blueprint is that possibilities for that species. That's the identity. This is what makes cattle, cattle, trees, trees, and vegetable plants, vegetable plants. Cells have an RNA, and these are the instructions for the individual cells to do what they do from the DNA. Enzymes are within the cells, and they're the operational workforce, and they carry out the instructions from the DNA, RNA, and they're converting and combining elements, building, removing, sustaining, maintaining all types of living functions. In humans, each cell has 6 billion pair of DNA. End to end, this comprises 2 meters of DNA strands per cell. The length of a DNA pair is 0.34 nanometers, which is 1/3 of a billionth of a meter. we have 100 trillion cells. Therefore, we have approximately 200 trillion meters of DNA in our body. If we put that into a distance, that's the equivalent of 55.8 billion miles of DNA in each of us. That is enough DNA to go to the sun and back from this earth 600 times. The distance of our sun is 92.96 million miles from Earth, or we could take our DNA around the Earth's equator 5 million times. Now that's part of the divine intelligence that's put into each one of us. And this is the kind of intelligence that I am going to side with in creation and managing life. Everything on our planet is alive. Microbes, these are the unseen majority. Microbes were the first living organisms on this planet after the formation of elements and structure. These can be single cell microorganisms up to multiple cell microorganisms. They're good guys and they're bad guys. They function in the soil, they function in plants, animals, humans. They have the role to support all living systems. And there is not a single living system on this planet that does not exist without the support of microorganisms. They cycle nutrients, the critical role in the immune system. As humans, as much as 80% of our immune system is the function of microorganisms in our intestinal tract. So we have good guys there and we have bad guys there. This is no different than the soil. We have soil microorganisms that are very beneficial. We have soil pathogens, and we see this when we experience root disease, tissue disease, and plant diseases. So these become a very, very crucial component of this intelligence that we're managing. So look at the microbes within us. And again, understand the depth of engineering here. Each human cell in our body, which we have approximately 100 trillion cells, there are 10 microorganisms, at least 10 microorganisms on us or in us. That means for the average 100 trillion celled human, there are 1 quadrillion microorganisms. Each human in our DNA, we have that 6 billion pairs of DNA, that incredible length of 55.8 billion miles. Within that DNA, there are approximately 20,000 genes. Those are then put into 23 pairs of chromosomes. For every human gene, 20,000, there are 360 microbial genes. And that's just in the 10,000 unique identifiable species that we've already identified. It is likely that the identified species, now that we're able to do this, will go up to 35,000 or more. That means for our 20,000 genes that are in our DNA, we have over 8 million microbial genes that are also in our bodies, turning on and off our genes. And so the question I'm going to pose to you here is, who is running who? Beneficial microbes break down complex inputs into simpler nutritional elements suitable for absorption. They deliver nutrition, they contribute vigor and health, they control and suppress pathogenic populations. We're going to try to move through, we've got about 5 major topics that we want to try to get to. So we're going to move through some of this material as quickly as we can to try to get as big a scope of information across as we can. And so basically the rule is beneficial microorganisms produce health and nutrition. Pathogenic organisms are going to produce toxin, weakness, and disease. They invite and encourage other pathogenic organisms in tandem to create additional diseases. So here is a tale of two wolves. One evening, an old Cherokee told his grandson about a battle that goes on inside people. He said, "My son, the battle is between two wolves inside us all. One is evil. It is anger, jealousy, greed, arrogance, resentment, inferiority, lies, and ego. One is good. It is love, joy, peace, hope, humility, kindness, empathy, and truth." The grandson thought for a moment and asked his grandfather, "Which wolf wins?" The old Cherokee simply replied, "The one you feed." It's exactly the same truth with the soil or intestinal or gut microflora. Which one wins? The group of microorganisms that you feed. Okay, we're going to go into a mineral presentation and pick up the intelligence within mineral elements, because we want to do a little definition on how elements are put together, their structure, the intelligence that they have, and how they're used. God left the world unfinished for man to work his skill upon. He left the electricity in the clouds, the oil in the earth. He left the rivers unbridged and the forests unfelled and the cities unbuilt. God gives to men the challenges of raw materials, not the ease of finished things. He leaves the pictures unpainted and the music unsung and the problems unsolved, that man might know the joys and glories of creation. In agriculture, we're told that we have 17 essential elements for plants to survive. There are positive elements, there are negative elements. There are a tremendous amount of beneficial elements that we do not understand the full use and application of. They're used not only in the building of plants, they're in all life forms. When we look at the atomic structure, we have, of every element, we have a nucleus and we have electrons. The nucleus can be comprised of protons and neutrons. The electrons are always orbiting the nucleus. The center is positive, the electrons are negative, and this is the electrical attraction that hold elements into a stable bond. So when we look at how elements are put together, God uses one very brilliant pattern and he simply repeats it. The use of protons, neutrons, and electrons. And it's simply the number that changes the structure of the elements and also the energy of that element and the vibrational frequency of this element. So we look at hydrogen, we have one proton, one electron, and it has an atomic weight of just slightly over 1. As you look at helium, the pattern is multiplied: 2 protons, 2 neutrons, 2 electrons. The electrons will always match the protons. But helium has a different energy than hydrogen. And as we look at lithium, we have 3 protons, 3 electrons, and 4 neutrons. And the weight changes, as does the energy, as does the intelligence. As we look at a summary sheet of the different elements, we can see the number of protons, electrons, neutrons, and the various weights. And so obviously, they're all structured different, and they're all meant to do different things in every form of compound, in every element, and in all living systems. God programmed, just as he programmed the microorganisms, everything is programmed with its own intelligence. So when you look at 5+ million species of bacteria in the soil, they're all individually programmed, not only with their physiological functions, but their intellectual functions. And God put this together. And those intelligences are here for a reason. They already understand what their interplay is between soil minerals and plant life. And we understand more and more as we watch this interaction happen that soil microorganisms understand the plants. They understand the soil minerals, and they function as the mediator between making minerals available in the correct form for the plant. So all this intelligence is interconnected. And if we don't understand that, you'll be fighting it and struggling with disease as long as you try to manage this intelligence. How they're structured is carbon is the 6th element. It has an atomic mass of 12. And these elements are very, very small. It takes almost a trillion atoms of hydrogen to equal 1 gram. These are massive, massive numbers, but they all have a weight and they're all present. When we look at the individual atomic structure, water is 18, aluminum is 27, phosphoric acid is 98, gold is 197. And this is how it's done. It's a very simple process of mathematics. Hydrogen, oxygen has a molecular weight of 18. Carbon dioxide, we have 12. 16 and 16, it's 44. Nitrogen gas, 14 and 14 is 28. Oxygen is 32. This is how God puts things together. So when we start looking at what makes up a plant, we can take the plant's dry matter weight and look at what is comprising the elements within this material. Carbon, 45%, oxygen, 45%, hydrogen, approximately 6%, nitrogen, 1 to 2%, on average about 1.5%. So I have 4 elements that make up 99 or 97.5% of all the dry plant matter out there. That's above and below ground. We have, and these are gases. Then we take additional 4 elements of magnesium, potassium, calcium, sulfur, phosphate. 5 more elements make up approximately 2% of the plant's dry matter weight. So of all the elements that we have in the periodic table, which were at 117, we have just 9 that make up 99.5% of the plant's dry matter weight. And I want to make specific note here about carbon and oxygen. 90% of the plant's total weight is carbon and oxygen. Okay, there's an incredibly good book of research done by N.L. Krishilnikov. He was the compiler of this research from the late 1800s until about the 1950s. And this was from the Institute of Microbiology, Academy of Sciences in, at that time, the USSR. The most important component of soil atmosphere is carbon dioxide, the final decomposition product of organic matter. The intensity of this biochemical processes taking place in the soil can be adjudged by the amount of carbon dioxide released. The formation of carbon dioxide depends to a large degree on the microbial metabolites. Everything that favors the growth of organisms, microorganisms, increases the generation of CO2. So microorganisms are just as you and I are. We inhale oxygen, we exhale carbon dioxide. So go back to the plant's construction, and 90% of its dry matter weight above and below ground are these 2 elements. If you want yield, it depends on your microbial metabolism, the function and production of CO2. You kill your microbes, you kill the production of your biomass. Simple as that. Hydrogen, carbon, nitrogen, oxygen, these are the plant's dry matter weight percentages. The other half of 1% of your plant's dry matter weight are the trace elements. Now, these are not structural. We don't have enough of them to be structural, but they're incredibly important. I want you to visualize a tractor. We go out and we buy this beautiful green, yellow, or red tractor, and it weighs 50,000 pounds. Ask yourself, how far does that tractor go without fuel? I don't need 50,000 pounds of fuel. I need 5 gallons of fuel to actually turn this thing on and make it work. But it is a tremendous amount of biomass, but without something to activate it and start it and create energy, it doesn't work. Your plants are the same way. You can build structure with 9 elements, but those are not the elements that are primarily responsible for all of the plant's functions and all of the plant's nutritions and creations. These are the trace elements. Trace elements are the activators that start and run the plant functions. And the most important aspect of fertility is the balance between the elements. Not only is each individual element necessary, but a balance of all elements. So as you look at this, what this is trying to share with us is that we have all of these elements are interconnected. So for nitrogen to ultimately become a protein, it has to have 2 to 3 dozen assisting minerals, taking it from an elemental form into an amino acid, a peptide, or a protein, because there are hundreds and hundreds, if not thousands, of enzymatic processes that are going to take and change the nitrogen, carbon, hydrogen, oxygen into various compounds that go into all parts of the plant, all parts of physiology and insects, in plants, animals, and humans. This intelligence is there. And so if I actually want my NP and K and my base building block elements to function, they have to have trace elements to get them to a finished product. You can take a simple material like soft rock phosphate, do a total analysis, and you can begin to see all of the minerals that are in soft rock phosphate. There's a tremendous amount of elements out there, and you can take and do this out of any rock in the field. Trace elements also suppress pathogens. If we have adequate trace elements in the soil, the very presence of minerals suppress pathogens. And that is one of nature's way of controlling pathogens besides beneficial microorganisms. Molybdenum, for example, is required for the nitrogen utilization. But molybdenum also blocks vomitoxin formation. It suppresses Phytophthora, and it inhibits pathogenic nematode. And when we do soil tests, what we find is virtually no one has adequate molybdenum in their soil. This is a trace element that we've used for decades, if not centuries. Every time that we've grazed animals, we've produced a crop, and we've sold that product, we sent minerals down the road with it. And now what we're doing is we have very depleted soils, and we don't have these trace elements in adequate presence to either run plant functions and or to suppress pathogens. When you look at manganese, okay, it reduces fungal and bacterial disease. It stops or inhibits pathogenic growth, sporulation, toxin production. It enhances physical properties of the plant's defense mechanism through the structures that build the plant's cellulose structure. These are the polyphenol oxidase enzymes. Glyphosate is incredibly devastating to the manganese-reducing bacteria that are in our soil, while it drastically stimulates pathogens. Zinc is a very common deficiency in our soils and in our plants. Zinc runs over 300 enzymes. It is absolutely crucial for microbial enzymes. It modulates the phytotoxins and mycotoxin production in pathogens. It inhibits the production of fusarium C, and it has direct effects on the fungal growth and secondary metabolism. This is a very, very critical thing when we talk about trace elements. It isn't just the plants that need the trace elements. Microorganisms function by producing enzymes. If the trace elements aren't there for the plant, They're not there for the microorganisms, and neither are going to function. Therefore, when components are put together, that which grazes or lives off of the plant material is not going to get the trace elements to function, the enzymes within their system either. Copper promotes lignin formation. The polyphenol oxidase enzymes runs off primarily copper and manganese. It's absolutely essential as an antimicrobial. And when you have copper up high enough in your soil, you have a broad spectrum disease suppressant. Boron, very, very critical for structural and metabolism defense. It's with calcium, maintains your strength and integrity of your cell walls, preventing pathogen penetration. And again, maintains calcium within the cell to provide resistance to these pathogenic organisms that come in. They produce a peptic enzyme that is to break down the cellulose structure. If it's put together properly, that doesn't happen. Empty food. The alarming fact is that food, fruits, vegetables, and grain now being raised on millions of acres in this land no longer contain enough certain needed nutrition. We are starving us no matter how much we eat of them. Check out the date on this document to the U.S. Senate, 1936. Do you think we've gotten better or worse since then? Every report from this country and every other country has an emphatic answer that our food has continued to decline in nutrition over the last 150 years. Brix, this is an indicator of the sugar and the mineral content in plants. And what it does is minerals and sugars go together. You get your Brix up high enough, which is your sugar and mineral content in a plant, they have their own immune system in place. So for example, on a Brix chart, you have poor, average, good, and excellent. This is a refractometer and a pair of vice grips that we use. This is a strawberry at 6.2. On the chart, it would read poor. This is why strawberries from the store have very little flavor, they don't last, and they spoil. We're going to talk about this as we get into this. Nature's way of recycling material is to let it spoil. Pathogens cannot eat high Brix mineral content foods. They can eat low nutrient, low sugar, low mineral content foods, and that's all. This is another way that God separated the pathogens from the beneficials. Mineral availability, when we look at soil, the pH is between 6.5 and 7.5 is where we have this complex of soil availability. In our roots that are around our soil material, we have a soluble, extractable, and an exchangeable pool. The bacteria and fungi organisms can work from the total and extractable, or the exchangeable and extractable pools. The plants use that which is soluble. Here's a material that we use, and what it does is it releases micronutrients into the soil. It's an organic mild acid produced by microorganisms through fermentation, but you can take any mineral here and you can see how it is simply increased by the release of certain bonds off of the clay. And so your boron will increase from about 0.6 up to just about 2 to about 3.3, depending on whether we're using a half a gallon or 1 gallon of this material. But it releases everything positive and negative. Potassium goes up from 5 to 69 to 168. And so this is not a process of mining the soil. When we take something out, we need to put something back. But I want you to notice the column with molybdenum. We don't have most molybdenum in our soils. And that's a crucial element for not only the microbes, but also for the formation of proteins. When we look at just missing a few elements within our plant production or our food, look at potassium difference in tomatoes. When tomatoes are yellow or discolored inside, it is a potassium deficiency. look at the potassium difference in just 1% in oranges. The physical properties of soil, 25% air, 25% water, mineral content, and ideally it's 4 to 5% humus. Soil is formed from decaying rocks and plants and animals, and bacteria and fungi break things down and build things back up. We have a lot of different types of soil in this country, 70,000 different types in the US alone. It takes more than 500 years to produce 1 inch of topsoil. And that's only about a dime's thickness over an acre, 5 tons of it. When we look at the structure of soil, very coarse sand, the 90 particles per gram approximately. We get into fine sand, we're up around 45, 46,000. When we get into silts and clays, which we can't see, we're at approximately 6 million to 90 billion particles per gram. This is the holding capacity of soil. We look at CEC. Sand is 1 to 5. We have loamy sand, 5 to 10. Different clays go to 10 to 20. And on up, organic matter is 1 to 200 in holding capacity because it's so negatively charged. In essence, our cation exchange capacity in our soil is 1 hold. 1 negative can hold 1 positive. 10 negatives hold 10 positives. This is, in essence, the fuel tank of the soil. How much mineral capacity do we have to hold? You have calcium, magnesium, hydrogen, potassium, and others in your cation exchange capacity that we measure. And so we have positively charged elements. These are our cations that are hooked to the negatively charged clay, silts, and organic matter in our soil. And this is how nature holds positives and negatives. They hold it by electrical magnetic attraction. And the cation exchange capacity is simply the amount of negatives holding the amount of positives. And this is what your soil retains as availability for your biology and your plants. Cations are all positive, anions are all negative. We have to have a certain amount of essential elements just to get our plants to live. The soil is the assembly life, is the assembly line of all life that lives from it. Let me say that over again. The soil is the point at which the assembly lines of all life take off. That's Dr. William Albrick. Soil is made up of water, air, inorganic matter, and organic matter. You can break each component down. Organic matter, again, plants, animals, biology. There are indications that plant roots not only release, but also actively absorb CO2. The amount of CO2 taken up from the soil may be of the same magnitude as that coming from the atmosphere or even exceed it. The intensity of CO2 absorption from the soil depends on its concentration. The higher the concentration of CO2 in the soil, the quicker it finds its way into the plant via the roots. Now, this is new information to us. We think that all CO2 is absorbed above ground. It is not. Okay, we want to go into biology here real quick, and we'll try to speed this up because we want to look at how these microorganisms are programmed to do what they do and how God creates fertilizer through the process of interaction of soil microorganisms. When we learn to reproduce the fertility instead of buying it, our profit potential increases exponentially. Microbial. Okay, microbes put things together and they take things apart. And this is predominantly a function of their enzymes. They create biochemical processes. They form new compounds. They decompose older substances that need to be recycled or done back into simpler structures. All life, human life, animal life, soil life, depends upon the chemical, the physical, and the biological. And the microbes are actually running all of this. When we look at the soil, we understand that we have microorganisms and earthworms and all that wonderful stuff on and in the soil. But we should also have a full complex of microorganisms on the plant leaves. That is the second nutritional component of the plant. The first one is the roots. The second one is the leaf structure. Microorganisms decompose the plants and animal residue. They add to the soil. They liberate nitrogen. They oxidize and transform fertilizers. They produce organic food. They are incredible for seed germination, build soil structure, reduce compaction, retain water. So we have all of these wonderful microbes in the soil food web. We have all these trophic layers of what everyone's doing. We want to take a look at this. And I want you to pay particular attention to the carbon to nitrogen ratio of these microorganisms, because this is where God introduces another element of math. And it's absolutely genius in how this works. So bacteria in general are 5 carbons to 1 nitrogen. Okay. And also keep in mind that it isn't just carbon to nitrogen, it's carbon to phosphate, potassium, calcium, sulfur, magnesium, etc., all through the trace minerals. Bacteria are the most nutrient-dense organism on this planet. Pure protein is 3 carbons, 1 nitrogen. Bacteria, as a living organism, contain more nutrition than any other form of life on this planet. Fungi are 20 carbons to 1 nitrogen. We got good guy bacteria, good guy fungi, and we got pathogens, okay? And the response of the microorganism is who you stimulate, who you grow, who you nurture, and how you alter the environment to feed them. The next group of microorganisms are protozoa. They are predators. They do not eat and decompose plant material or materials such as animals or other microorganisms. These guys are predators. They're meat eaters. Their job is to eat bacteria. They're 30 carbons, 1 nitrogen. You and I are 30 carbons to 1 nitrogen, and we eat that which is in our carbon to nitrogen ratio. Nematodes, they're 100 carbons to 1 nitrogen, and they primarily eat fungi, and that's their job. And we're going to look at how these carbon to nitrogen ratios interplay. Then we go up into our micro and macro orthopods. Our carbon to nitrogen ratios get even wider. Now, everything in the soil eats something. Everything in the ocean eats something. Every life form on this planet eats something. And so we're all eating off of these food chains. This is how God arranged the cycling of nutrition. We go up into earthworms, gastroarthropods. We go up to reptiles, mammals, and birds. And so as plants emerge, there could be 10 carbons to 1 nitrogen. As they grow, they're adding way more carbon dioxide than they are nitrogen. And so when a plant gets into maturity and seeding, it can be 50, 70, 80 carbons to 1 nitrogen. When they're dead and senescent, they're upwards of 100 to 200 to 400 carbons to 1 nitrogen. When you watch a cow graze in the field, they don't want the tall grass. They want the short grass, because the carbon to nitrogen ratio is at their ratio or less. They're smart enough to understand that if they're at 30 carbons, 1 nitrogen, they're not going to live and maintain their ratio eating 50 or 70 carbon to nitrogen ratio material. So they don't touch it. We're the same way. We like those things at or near our carbon to nitrogen ratio. CO2 is more important to high yield potential than N or any other element. And again, we're going back to carbon, oxygen, and it's 90% present in plant dry matter material. Okay, we've talked about this earlier. Carbon dioxide is what is produced by microorganisms, and that is the basis of your plant biomass. It is actively taken up by the roots. The more of it you have, the faster your plants will grow. Every plant that we grow out here has a proper bacteria to fungal ratio. If we want to encourage weeds, we just put in high bacteria. The vegetables, the row crops, are about 1-to-1 ratio, 1 bacteria to 1 fungi. In addition, as we get into woody plants, they now become fungally dominated, to where our vines are 5 to 10 fungi to 1 bacteria. Our fruit trees can be as high as 200 fungi to 1 bacteria, conifers 500, and old growth forests up to 1,000 fungi to 1 bacteria. So when we're growing plants, we've got to make sure we get the right microorganisms underneath these plants so that they feed the plant properly, because some plants are alkaline in nature and they need an alkaline soil, which comes from bacteria. Other plants are acidic in nature, and that environment comes from the acidic strands of the fungi. Our microorganisms are going to parallel our plant's growth season perfectly. So here's where God's math comes in and how nutrient cycling occurs in the soil. Bacteria, 5 carbons to 1 nitrogen, but it's also potassium, phosphate, calcium, sulfur, magnesium, iron, manganese, copper, zinc, boron, cobalt, all the way down the line. Fungi 20 to 1, 30 to 1. So protozoa come over and eat bacteria up to 10,000 a day. For a protozoa to maintain 30 carbons and 1 nitrogen, he has to eat 6 bacteria at 5 to 1. But at that point, he also has 6 nitrogen. He can't keep 6 nitrogen. He has to excrete 5 nitrogen back in the soil. Goes back out as NH4, ammonium, and the plant takes it up because the plant is putting out sugars. The microorganisms, the bacteria and the fungi, go to the root, start multiplying, and the protozoa come in and start eating the bacteria. The nematode eat the fungi. The mineral release is on the root system for the plant. So again, it is a larger organism eating a smaller organism, a lower carbon nitrogen ratio, excreting the difference. And this is how God maintains the prairies and the plains and the forests. In all of our soils, we have all of these tropic levels of microorganisms. Earthworms won't be there unless everything underneath them in the food chain is present. And we want these microorganisms because they're eating and they're releasing nutrients for our plants. These are soybean nodules. So just a single rye plant, we start looking at how God creates infinity in a finite area. This was also done by the Russian study. A single rye plant root length has 377 miles. 80% of that were feeder roots. The reason it took 2 years to complete because they had 14.5 billion roots. The fibrous length is 6,200 miles. When you combine the roots and the root hairs, we had almost 7,000 miles, or an acre and a half of surface area. Again, these plants have incredible intelligence. They have incredible presence. Plant roots produce exudates from photosynthetic compounds. They feed the microorganisms, and that is the intelligent communication between plants and soil biology. Corn plants have approximately 300 miles of root, and mycorrhizal fungi who can enter seed into the root and infect it and grow from the nutrients provided by the plant can increase the root equivalent in the soil by tenfold. Plants with biology, plants without biology. This is a field in Minnesota where we have soybeans being on a biological side. This is a transitional side. This is the chemical side. You simply look at the plant and you get the biological response. There's only 150 feet between the chemical side and the biological side. Here's a corn plant with 6 ears. This is an alfalfa plant with approximately 9 nodes. And in this stem, there are dozens and dozens and dozens of potential nodes, but they're not activated. With some mineral and microbial nutrition, 100 feet away in a different part of the field, the same plant will produce 17 functional nodes and more leaves. So the potential in the plant is dormant unless there are nutritions and trace elements supporting the nodes. We currently have up to 27 nodes pushing out branches and leaves on alfalfa plants. And there's more in there. We haven't learned how to get them out yet. Glyphosate is a massive suppressor of good organisms, and it stimulates the pathogenic organisms, whether it's Phytophthora, Pythium, Fusarium. So when you apply glyphosate at various rates, what you're going to see is a massive increase in your pathogenic populations, and you're going to see a strong decline in your Pseudomonas, your manganese reducers, and your beneficial microbes across the board. Roundup will, at 1/10 of 1 part per million, will begin affecting beneficial microorganisms. It takes up to 4,000 times more glyphosate to kill pathogens. And so your glyphosate compound is a very, very potent antibiotic, specifically on the beneficial microbes first. And that's why we see such a massive switch in soil populations when we apply glyphosate. We're decimating our beneficial soil microorganisms. We're destroying that life and health in the soil, and we're absolutely exploding our pathogenic populations. We also lose our mineral components in our plants. We can see the difference in the plant roots as far as disease response. Glyphosate by itself cannot kill a plant. It can stunt a plant. It will pull the positive trace minerals away from the enzymes and shut the plant down. Glyphosate is phosphate based. It is negatively charged, and it's going to electromagnetically pull the trace elements, and it shuts the plant's defense mechanisms down. Having killed the beneficial microorganisms in the root systems, the pathogens then come back in and they attack the root. And so you have a two-step mechanism with glyphosate or Roundup working. One, you shut the plant down. The second one is you kill it with a pathogen. And that is the process by which glyphosate works. You can see in these fields where you have glyphosate-induced mineral deficiency, these soybeans have turned bronze because the manganese and the magnesium have been chelated by the glyphosate, and the plants will not get their green back until they replace that mineral they lost in the glyphosate applications. Right here, you can see where they didn't spray these particular soybean plants, and they're still green and functional. Everything else had the minerals taken away from it. You have a whole series of diseases. You can see the mineral loss, which will weaken the plant. These are some farms that I had worked with up in Montana. They were spraying a lot of glyphosate. It brought on a disease called take-all disease, where the pathogens would go in and destroy the root systems, and the plants would die early in maturity, and there'd be no grain in the heads. So you can see the blackening of the crown and the loss of the root system. This particular pathogen is responsible for this, and it's just overstimulated by the presence of glyphosate. In Roundup Ready corn, because it chelates the copper and the manganese, the polyphenol oxidase enzymes do not put these stalks together as strong as they could be, and they go down in wind. Glyphosate in our systems, in 2016, 70% of Americans had detectable levels of glyphosate in their system. Between 1993 and 2016, glyphosate levels in people's bodies increased by 1,208%. They found that people who regularly ate organic food had 80% less glyphosate than those who rarely ate it. Glyphosate is prohibited in the application in organic food production. These two researchers from Sri Lanka who were determining the kidney disease that was happening to the cotton workers, where they were losing approximately 25% of the field workers, noted that the adjuvants added to glyphosate-based herbicides are 1,000 times more toxic than the glyphosate itself. The point I'm trying to raise is that glyphosate without adjuvants is not very useful. Therefore, manufacturers have added these toxic chemicals into glyphosate and nobody is talking about them. Over the last 25 years, the pesticide industry had hoodwinked us by referring only to glyphosate and not to the adjuvants that were in these herbicides. If you look at the radiation damage, there is a method of calculating radiation damage, not only from hydrogen bombs, but also from chemical radiation. And so there was some computation that was done in Italy, and it was in the agricultural research scientific area, where they were looking at the radiation from chemical damage, and they related it back to hydrogen type bomb damage that we used in Japan to end World War II. So you look at this, ionization of synthetic chemicals mimic the same damage as atomic fallout. In 1992, worldwide, we were using 1,158,000,000 pounds of synthetic pesticides. Now, this is exclusive of fungicides, herbicides, and desiccants at the time. Cellular damage equivalent to 72,500 type Hiroshima bombs annually to the planet. Now, this is all pre-glyphosate. Glyphosate alone now exceeds 5 billion pounds annually. That's 5 times more than we were using in 1972 of just pesticides. That is the equivalent now worldwide of 362,500 atomic bombs. So you look at the radiation fallout. That is exclusive of pesticides, fungicides, and desiccants. This is glyphosate alone. In the US alone, we apply 3 million pounds of glyphosate a year. That equivalent is over 60,000 atomic bombs each year. And this does not include the pesticides, fungicides, and desiccants that are used in addition to this. And you don't need to ask yourself, why are we sick? Why is every degenerative disease escalating in this country? Enzymes, these are the marvelous little things in microorganisms, plants, animals, and humans. We all come with our own individual enzyme package. And what these do is they put things together, they take things apart, and they change these wonderful compounds. Our DNA is made of that, our carbohydrates, our amino acids and proteins. And again, we have to have trace minerals, cofactors, to make all this work. Nitrogen has to have molybdenum to go from an element to a compound to amino acids to proteins. They're all interactive. Every mineral has to have several dozen assisting minerals to get it there. In our soil microorganisms, we have protozoa, we have nematode, we have good guys. This is an amoeba-eating bacteria. We're going to try to move through this fairly quickly. They decompose organic residue, they form soil humus, they take compaction out of the soil, they fix nitrogen. They improve water filtration, tillage, softness of our soil, we decrease erosion. Crop residue, we put soil microorganisms on corn in the Midwest. We looked at the soil a year later and it's clean. We've got earthworms, we've got earthworm here, we've got holes where the earthworms are moving through the soil, we've got a macroorthopod, and we've got about 5 rows of tip back that didn't quite fill on this corn. Let's go into the side of the field 100 feet away that got no microorganism activity. As we started to dig between the rows, you could see a lot of organic matter still there from the previous year, 11 months earlier. There's been no decomposition of much of the corn material. You can see how the material of the plant is stratified in these clods. You look at this compaction and almost petrified material sitting in these dirt clods. It's not breaking down. This soft pulpy core in the corn should have been gone in 2 weeks. It's 11 months later and it's still there. there's about 15 missing rows on this particular ear because the nutrition isn't there. The Russians will tell us that 66 to 75% of the soil nitrogen is not in the humus, but in the microbial proteins. And this is again where the microbes hold the mineral content. The protozoa come back and eat them and release the minerals for the plants. Microbes are present only if there is a correct food source for them. Pathogens are attracted by a different food source than are beneficial. Again, this is a division in nature where God does not allow a pathogen and a beneficial to do the same things, and they do not. What this is saying is that we have microflora that are antagonistic. These are the beneficials that produce antibiotic substances to suppress their competitors or pathogens. Soils have the ability to govern and control and clean themselves. And so this is through the good guy, bad guy balancing. And when we put products in that promote the beneficial microorganisms, they expand. When we put products into the soil that kill the beneficial populations and stimulate the pathogenic populations, we're going to see more disease and less plant production. Then there's a series of mycolytic bacteria that suppress all kinds of fungal pathogens like Pythium, Verticillium, Fusarium. And we have pathogenic nematodes that are eaten by fungi. And we have some pictures where you can actually watch the nematode trap the nematode get trapped by the fungi and eaten and removed from the system. Very fascinating process. Trichoderma, beneficial fungi are very effective against Rhizoctonia. And we have actinomyces that control a lot of pathogenic microorganisms. One other thing that we need to be aware of is mineral fertilizers do not diminish, but on the contrary, they noticeably increase the contents of inhibitors or pathogens. Mineral fertilizers refer to inorganic chemical fertilizers devoid of activity. So a lot of the refined products that we buy from the fertilizer companies are stimulating the pathogens in our soil out there. And what the research tells us is that our soils have the ability to rid themselves of the pathogenic bacteria coming into it. This is the self-purification process. And what I will tell you, we've seen this over and over, microbial warfare depends upon one factor. He who has the most wins. When we promote the beneficial microorganisms, they keep the pathogens in check. Microorganisms on the leaf surfaces play a role in plant protection and nutrition. It is well established that plants can absorb various microbial metabolites, vitamins, antibiotics, and other compounds through the leaf surfaces. These substances not only enter the plant through the leaves, but they can be introduced by this route into large quantities for the purpose of feeding, as well as for fighting bacterial and fungal infections. And so earlier I mentioned that we have the root system. We have the entire foliage that we can put beneficial microorganisms on and grow those colonies, one, as a protective barrier against airborne pathogens, but also to produce nutrition from the air. Microbial mineral tea, these are tea brewers that we use. We grow a huge population of bacteria, fungi, protozoa, and we put these back out in the soil. And this is an amazing process of reestablishing beneficial microorganisms into places that we don't have them, or we've altered the populations into pathogenic or unfriendly bacteria. You have large brewers, you have very small brewers. This is a 9,000 gallon brewer that one of our major farms up in Montana uses. They're brewing constantly from about April to October. This goes over about 8,000 acres. This is some wonderful results of microbes and soluble minerals. We have some wonderful distributors that work with us up in Washington, and they work primarily with gardeners and small farms. This was an abandoned tomato plant. This is microbial mineral T given to that tomato plant, and you can see what a nice recovery it was. This is Len, and these are several of his cherry tomato plants. This is several years ago, one of Len's strawberries. It's on a 55-gallon drum plus about a 1-foot base. These are Len's strawberries now, using biology and mineral T. This is Len's pea plant. This is a field that we treated with soluble minerals in Nebraska, and we had a 36% increase in the third crop of alfalfa. The fourth cutting that year increased 45%. By the following year, we had an increase of 63% in production. And this is what the size of the leaf and the plant look like. We didn't quite get to 10 ton per acre. That was our goal by 2012. It took us until 2014 and 15 to do that. We had to replant, come back in. We produced more than 10 ton of alfalfa that year. And so, Jared, I know that we've gone over our time. What would you like us to do? There's a couple more things we could share, but this is your presentation. Tell us what you'd like us to do.
Yeah, this is great. I would just say if anybody wants to jump off, it is going to be recorded. We want to honor your time and sure appreciate that in the participants. But I would say my vote would be to go ahead and push through. And I shared a link in the chat box, which is a link to YouTube, and the video will be posted there.
Okay.
So
we're going to show you some incredible results from putting biology and minerals on the seed. This isn't a very long presentation, but I want to give you some potential of what is out there just by working with the fertilizers and the microbes and the minerals. And then we're going to talk real briefly about plants and pathogens so you understand this. And then we're going to talk ever so briefly about plant primary and plant secondary metabolites, because this brings this whole thing full circle. In what we do, we get to work with soil minerals, and we do that analysis. We look at soil biology, we do that analysis. Then we grow the plant, and we look at and we study the plant. Then it's fed to livestock. And at any given time, we have millions of chickens on our probiotics and our minerals and our feed. We have hogs, we have cattle, we have sheep, we have horses. And then we also have food production that goes into the human chain. And so we get to look at every aspect of life at all through the entire food chain. And there is such a dramatic difference between food that is produced without nutrition, that is just biomass and has no flavor, it has no mineral content, to that which is healthy and sustains life. And it doesn't happen just because we grow a plant. It happens only because we understand the mineral involvement, we understand the microbial involvement, and we step back and we allow that incredible divine intelligence that God put into things to do its job. And when that happens, we start to see pretty amazing results. And so this is some of the results that we've seen. So we put in a lot of different groups of microorganisms. We have about 13 different groups, probably upwards of 50 species. We have 85 or more micronized minerals. And then we have food sources for the biology. So we're going to put this on the seed. We have it in both liquid and we have it both in dry. And what it does is it helps with germination, and it dramatically will increase yields in good years and bad years. We have microorganisms now that have been harvested out of Yellowstone Park. And the biology was, why are these plants living at 150 degrees? How can they do that? How are these plants surviving at 50 below? And that was the extraction of a group of microorganisms that we now use in dry farming and even irrigated farming that help reduce with the effects of drought, heat, cold, frost, and salt tolerance. That's what these group of microbes do. And they're very, very effective. We have literally hundreds and hundreds of thousands of dry land acres in the West. And we are now moving these microorganisms into these fields and on these crops and in these farms. There's very small seed treaters that can be very effective at treating large amounts of seed. Seed treatment results in the real world. What we're adding is mycorrhizal fungi. We're adding nitrogen-fixing azotobacter. We're adding Pseudomonas, Bacillus, Trichodermis, Penicillium. Wonderful groups of microorganisms that continue to protect the plant and feed the plant. So here's some barley that was done by one of our farms up in Montana. They just took regular barley and they seed treated part of it with the biology and the minerals, and then they just kept them moist. And you can see what rate of germination is happening. It is very common for us to plant barley and have it up germinated in 3 to 4 days with 4 inches of growth in a week. Oftentimes the untreated barley won't be out of the ground for a week or longer. Here's one of the farms that sent us a picture of their wheat plants. And this was why they said, this is why we seed treat. Here is a corn trial that was done in the Midwest by a company called Byron Seed. This is their publication. We sent some seed treatment back. But what I want to show you here, the results of the treated side was the surviving population in the first field. And they did 5 separate trials, 31,000, 30, 32, 33, and 29,000. They average about 31,000. These fields yielded 254 bushel an acre. The untreated side of the field had a way lower survival plant rate and yielded 217 bushel. And so at $4.20 corn, this increased the revenue to the farm about $157. This was sold for $12 an acre. Here's a silage field where one part is treated, one part is not. You can get a really good look at the difference in the corn plants between the two. And then also we took the ears, the stalk, the height, the length, the kernels, the count, and you could just compare the two. Root size, root mass, dramatically different with the assistance of the microorganisms. Here again in Nebraska, we're able to produce over 10 ton of alfalfa per field. This is irrigated. We have our wheat fields in Montana. We are now pushing close to 5-inch heads. You can see every year this gets better, from 12 to 13 to 14 to 15. Our heads are getting bigger, they're getting longer, the soils have become more microbially dominated and life going back into the soil. I was up in Montana this spring. I wanted to share this with you. They got, up around Great Falls area, they got over 4 inches of rain in 4 days. And the rivers were flooding, the roads were flooding, towns were flooding, entire communities were closed. As I drove to our farms, I could see river of topsoil and silt running down these fields. When I got to our farms that had been using this program for 5 years, there was absolutely no runoff coming off any of their fields. They scarcely had a puddle of water in the ravines. Their farms were soaking up the water and retaining it as moisture, while the other farms had compaction and it was running off. This is dry land wheat near Billings, Montana. And we took and looked at the untreated side of the seed and we looked at the treated side of the seed. You can tell which one is massively larger in root and stem size. These are the heads from the dry land wheat. This crop yielded almost 100 bushel per acre dry land. These are the untreated heads and another section of the farm that did not use our products. You can see this was a picture they sent me of the untreated heads and the treated heads. This is another farm over in a different part of Montana on chickpeas. To the left are the untreated roots, to the right are the treated roots. This is a field that was sprayed with a foliar of microbes and minerals, and you can see the difference in growth size. This is the farm with the 9,000 gallon brewer. Here's this young man by the truck. These are sunflowers that were seed treated. A year ago, I sent dry seed treatment up to put on their corn, their dryland corn for the dairy off of this large colony farm. And we doubled their corn production for silage. This year, Abe took and the leftover dry seed treatment for the corn and put it on these sunflowers. And then he stabilized some phosphate with one of our biological products that stops the phosphate from tying up in the soil. And that's all he did to these plants. This field is an exceptional example of stabilized nutrition and microorganisms working together. Typical yield on sunflowers in this area is about 500 pounds per acre. Abe was able to yield over 2,000 pounds per acre when you consider the factors of bird damage and the harvest loss through their combines. And so again, you see the potential of having these microorganisms converting nutrition into your plants all season long. We use chlorophyll meters so that we can check the chlorophyll and the Brix. And by the way, 23.2 Brix on Durham wheat is exceptional. It is off the charts. And here's one at 619, here's one at 647. This is your chlorophyll becomes your plant production mechanism. Here again is your lentils. Roots are perfectly clean, excellent nodules forming nitrogen already. And so let's go into plant pathogens really quick. And
okay, we had a question, Ken.
yes.
So Matt asked, what hardware does it take to make the mineral tea, or the compost tea brewer is what he's referring to.
Okay.
What does the mineral tea consist of, and where do you get the bacteria? Where do you get the start for the brew?
Okay. We have a whole series of plans to build brewers anywhere from 55 gallons up to whatever size you want to go. We're happy to share those with you. And so we also have the recipes for either microbial mineral tea where you're growing microbes and you're dissolving minerals, or if you're just dissolving minerals and putting it out. So you can go to our website, which is biomineralstechnologies.com, and you can go into, Mike, what section is that? You got that in?
I don't know that I have it posted on the website, the document itself, but they can call us from there. The phone number's on there.
Okay.
And we'll send it to them.
Yeah, and or if you want to email us to the sales at bio or BMT.
Yeah, sales@bmted.com. That will get to us as well.
And we can send you the documents back. But you can get a hold of us. We'll be happy to share that information with you. Okay, plants and pathogen. This is just an incredibly fascinating law of nature that if we understand it, then we don't fight it. If I could live my life over again, I would devote it to proving that plants seek their natural habitat, diseased tissue, rather than being the cause of diseased tissue. That is, mosquitoes seek the stagnant water, but do not cause the water or pool to become stagnant. This is the father of pathology. Dr. William Albrecht said, the presence of insects, disease, and pathogens in the field is not the reason for crop failure. These are merely indicators that the crop has already failed. What's happening here is that nature uses pathogens to refine the gene pool. Plants that are unhealthy, unfit, not worthy of reproduction, and who will not provide the required nutrition for higher organisms are going to be recycled. Nature is very blunt about this. This is survival of the fittest, and this is how nature works. The message is, if you have pathogens attacking our plants, we have biology deficiencies, we have mineral deficiencies, those produce nutrient deficiencies. And nature is going to take it out of the food chain to protect the higher organisms, and this is how it works. Plant pathogens cannot eat nutrient deficient foods. They are only able to digest.
They cannot eat nutrient complete foods.
They can only digest incomplete compounds, whether they're carbohydrates, proteins, or fats. They have to be nutrient deficient. They don't have a digestive system that allows them to process sugars and high nutrient compounds. Simple as that. These are wireworms. They decimate plants and fields. Okay, we can deal with that. Here's a picture of diseased wheat where pathogens simply came in from the air, lit on the leaf, and began to produce a toxin which destroyed the leaf surface. Well, think about this for just a second. If a pathogen can come in, land on a plant and colonize, and then produce toxins, why in the dickens can't we produce a beneficial microbial population, put it on that leaf, not only protect the leaf, but feed it? Well, the answer is we absolutely can, and we should be doing this. Here's a chickpea plant up near the Canadian border in Montana where Sclerotinia pythium had gotten into the root, and you can see that that brown part of the root, the toxins had destroyed. The plants are struggling, they're yellowing, they're dying, and this is what plant pathogens do. The message here is that the nutritional program and the biological program is deficient. Plants have this incredible immune system, but it's activated by biology and minerals. Okay, now here's some amazing work that we were fortunate enough to be involved in the Midwest. In the US, we grow about 90 million acres of corn. Goss's wilt affects about 70 million of those 90 million acres to some degree, anywhere from slight damage up to complete damage. And so this is what we saw and what we learned through our testing and years of following this process. Here's a field treated by a biological product called BioImprove. Okay, now this is made from microorganisms. This is not a chemical, it's not a synthetic. This is not made by a biotech industry. This is made from the intelligence of microorganisms in a completely natural fermentation process. We've used this product at 1 quart per acre per season. This is our corn. Right next to us, the neighboring field at the same time has a complete and total death loss. Okay, these plants have died weeks earlier because the organism got into the plant and produced an enzyme that dissolved the cellulose structure, and the plant died prematurely. So you can see the left side of the field is protected, the right side of the field is dying. This is what happens. On the left side is our kernel of our cob of corn. On the right side, this is the premature death. But as we look at the stalk, that pathogen, the Clavibacter michiganensis nebraskaensis, infects that stalk, comes up to the node, produces an enzyme that dissolves the cellulose in this stock material. That destroys the migration of nutrition from the top down and the roots up, and the plant dies early. Well, you lose the yield, you lose the quality. So this is the analysis we engaged in 2 years ago. We started taking the non-treated corn, and from the base of the plant up, we looked at literally every inch to inch and a half. We took a row of kernels to see what the mineral content was in the treated and the non-treated. This is the BioImprove ear. And again, we took A, B, C, D, E, F, G row, and we looked at the minerals. Okay, this is what they look like laying side by side. However, when you put them under a light, a backlight, there's a tremendous difference that shows up. The top untreated kernels of the plant, the ones that died early, are nutrient deficient. They're cloudy, they're dull, and there's not a lot of protein or nutrition in them. The treated corn, that the pathogenic organism was stopped and was not allowed to do its damage, that lived to maturity 4 to 6 weeks longer, that continued to feel, had the hardness, the opaqueness, and they were absolutely opaque under these lights. And Mike, that's been here with me, actually did the grinding of these individual types of corn. Mike, do you want to tell them what you found?
Well, the untreated corn, the kernels basically just fell apart. You took a mortar and pestle and you just tapped on them and they crumbled. The treated kernels, we couldn't use a mortar and pestle. We had to use a coffee grinder. They were too dense. They were too hard. They would not break down unless I put them in a coffee grinder.
This is the tracer that we have. There are 8 to 10 of these in the world. We have one, and what it allows us to do is find the mineral content of whatever we want to analyze. So we can look at soil, we can look at plant leaf, we can look at dry matter material, we can analyze the mineral content from sodium to uranium. This is a photon scanner, wonderful piece of equipment out of Germany from Bruker. The software was written by Dr. Jill Clapperton, but what we were doing was looking at what happened to plants that die from disease versus those plants that are actually able to live to maturity with biological assistance. So here's the results. The corn that was treated with the BioImprove, we look at row A, the non-treated corn, row A. This is at the base of the ear. Silica, our plant was 160. The non-treated plant was 189. You would say, well, the non-treated plant is actually better. No, it's not. Silica is used by plants as armor. When a plant is under attack, it will have higher silica content. Now look at the phosphate. 1,728 in the treated plant that lived and survived to maturity versus 377 that was in the non-treated plant that died early. We look at sulfur, 1366 versus 809. Our potassium number at almost 2,900 versus 1,852. Calcium numbers are fairly similar. Let's go back to phosphate. Phosphate is the base of your energy molecule. It is your adenosine diphosphate, adenosine monophosphate, adenosine triphosphate. Without phosphate, you do not have energy. The other thing is all 55.8 billion miles of your DNA on the outer strands is structured with sugar and phosphate molecules. You are not going to have life, health, and vigor without phosphate. So if you are growing the next generation of plants, which seed do you want to use? The next thing you have to ask yourself, if you're feeding this grain, which seed do you want to use? Because the animals that end up with the non-treated product that the disease takes early has such a deficient mineral content. They're not going to gain weight. They're not going to have energy to grow. It's not there. You go down to row D and you see a similar thing. Silica, ours is lower, theirs is higher, as it should be. Our phosphate is 1329, theirs is 303. Our sulfur is 1271, theirs is 787. We have almost 4,000 potassium, they have over 2,200. And again, it's the mineral content. If this, what we learned from this amazing process of testing was that the starches and the carbohydrates come into plants early. It's the mineral content that comes in late. And when you prematurely have disease, stop that process. You do not put the nutrition into the seed, either for a feed or for the next generation of plant.
So Ken, what do those numbers actually represent? Is it a part per million?
Yes, parts per million, Jared.
Gotcha.
Okay, and our last little section here is on how plants put nutrition together. And this is actually the treasure trove of what plants are capable of. These are plant primary metabolites, these are plant secondary metabolites. And now we're going to start to tie all of this together. This is where we get a really clear understanding of what our minerals, our enzymes, and our biology is contributing into our food production. This is why either we're healthy or why we're sick. Okay? Plant primary metabolites. The first thing a plant does is produce carbohydrates from photosynthetic energy, carbon, oxygen, hydrogen. All it takes is those three elements to start forming carbohydrates. And when you look at plant structure, it's absolutely simplistically brilliant. You have simple sugars, which are your monosaccharides. Then you have disaccharides, oligosaccharides, and polysaccharides. Well, all God did was take a very simple structure of monosaccharides, put two monosaccharides together, and you have a disaccharide. Well, then you take 3 to 10 monosaccharides and you get oligosaccharides. And then you start putting lots and lots of monosaccharides together to get polysaccharides. So again, it's a very basic construction that just gets added to. And so as we look at this, you have carbohydrates, proteins from amino acids, okay? We have lipids and oils, okay? All of our living systems run on enzymes, okay? We don't breathe, we don't think, we don't move muscles, we don't process thoughts without enzymes running this. And then when you look at the activation of enzymes, we need minerals, we need vitamins. There are two groups of activators for enzymes. They're trace minerals and vitamins. And you have fat and water-soluble vitamins. And so there's a whole litany, a whole magnificent list of what minerals activate which enzymes that help produce which compounds. So this is all very documented. There's some wonderful research on this. The basic message is if the mineral is missing, the functions are dormant. Doesn't happen. Plants simply shut down that process. Enzymes are supported by microorganisms. Enzymes are destroyed by pathogenic organisms and toxins. So how your pesticides, fungicides, and herbicides work is they're basically enzyme inhibitors. They stop part of the function in the insect or the plant or the animal. Okay, again, every bodily function that we have, blinking, breathing, moving muscles, everything, processing thoughts is driven by enzymes. And this is why we need our trace elements. We need our vitamins. And it's important to have the trace elements to produce the vitamins because there are no vitamins in the periodic table of elements. They don't naturally exist as elements. These are compounds that are made by minerals and enzymes. And the other thing that's so crucial is Molybdenum does not substitute for cobalt. Cobalt does not substitute for copper. Vanadium and titanium and gallium and strontium do not substitute for iron and zinc and manganese. They are all very individual. Okay, most of our enzymes are proteins, and they make these biochemical processes happen at the rate of thousands to millions of times faster. Again, these are our cofactors, our trace elements, our fat and water soluble vitamins. So you can go back and do the research on this. You can look at manganese. This particular enzyme is producing all kinds of really cool sugars. That's what this thing is saying in a nutshell. All right. It's got to have the trace element, the enzyme, to produce all of these polysaccharides and glycoproteins. You look at molybdenum. This is altering the nitrate reductase and the nitrogenous enzymes. This is the conversion of our nitrates into nitrites. This is the conversion of our atmospheric gas N2 into symbiotic microbial nitrogen for legumes. This is how it works. Molybdenum's not there. The microbe and or the plant can't make these alterations. Nickel, you've got to have it for your urease enzymes and also for your superoxide dismutase, which is a wonderful, wonderful free radical eliminator. You look at your zinc element. Zinc alone runs over 300 enzymes, and there are thousands of enzymes. And without these minerals, these enzymes are shutting down. Now think about this. If zinc is going to activate this carbonic anhydrase enzyme, this is going to start a compound. This is not the end of what it's making. There could be hundreds of enzymatic processes behind this particular enzyme. It will pass it from this enzyme to the next enzyme to the next enzyme, all relying on different minerals to ultimately make these carboxyl groups. And we've got to have that chain intact. When it breaks partway down the assembly line, this becomes an incomplete carbohydrate or an incomplete protein. And nature understands this, and it will come in and destroy it. This is amazing research that was done back in the 1950s by Dr. Philip Callahan. And what he learned through his research was that plants emit electromagnetic frequencies, and insects interpret those. And what they're doing is they're analyzing the plant's nutrient content, because if the minerals are missing and the formations of nutrition is missing, the signals that the plant emits are different. And they understand through their divine intelligence which they can eat and which they cannot. And that's the division. The plant is literally signaling out there into the world what it is developing and containing. And nature will allow it to live or take it out at that point. You look at your B vitamins. You can look at as a coenzyme, the enzyme class and what it's doing. So you've got B1s and B2s. You've got B3s and B6s. You can't produce cobalt or cobalamin without cobalt. It's B12. Everything will die. Our animals and us will die without B12. You can look up all of the minerals, all of the enzymes, all of the functions, and you can go on and on and on looking at how things are put together, how things are run, and what products are produced. So when you go into plant primary metabolites, you have carbohydrates first. They come from sun, carbon, oxygen, hydrogen. There's some mineral, and we have all kinds of sugar formations. It's just a marvelous process. Then you have proteins that form next. Okay, this is adding carbon, hydrogen, oxygen. Then you're adding the nitrogen and sulfur that you're going to start producing amino acids, peptides onto complete proteins. Next comes your lipids, your fats and oils. This is the development of your omega-3s, your omega-6s, and your omega-9s. And this is the additional energy that's required. Your lipids, these essential fats, are all phosphate-based. This is not your energy you want to be without in your plants, your livestock, or mankind. Now, the most fascinating part of all of this are your plant secondary metabolites. And this is where this incredible brilliance of divine creation comes into place. And we're just going to go through some of this fairly quickly, but I want to give you an idea of what plant potential is. Okay, so plant primary metabolites, they help plants deal with sunlight, UV radiation, antibacterial, antifungal. Plants are always communicating with their environment. They're attracting pollinators, but they're also repelling herbivores that eat on them. They send signals through the air and through the soil. They have diminished levels of function because of pesticides, herbicides, fungicides, okay? These plant secondary metabolites inhibit the growth of competing plants. They help them with temperature, tolerance, all kinds of wonderful things. But let's look at what they are. Okay, so here is the structure of some plant secondary metabolites. What we're going to do is look at what they are, and you actually know a lot of what these are. But as we look into what they're producing and how they produce it, we're going to get a really good look at what is or is not happening in our food chain, okay? So in plant secondary metabolites, you have four major groups. You have alkaloids, terpenoids, phenolics, and sulfonated amino acids. Now, you know what some of these are. So let's look at our alkaloid group. Caffeine, nicotine. Any of you cattlemen lost cattle from larkspur due to paralysis of the respiratory system? That's an alkaloid. Morphine and cocaine are all alkaloids. Terpenoids, let's look at one particular class, essential oils. Now I know you guys, a lot of you guys or your wives are familiar with these. They're terpenoids, right? The yellow in our egg yolks, our butterfat, and our lard, these are carotenoids or carotenes. They're, again, terpenoids. We have rubber, we also have cardiac glycosides. All right, now we're going to go into some phenols. These are flavonoids and non-flavonoids. And in the non-flavonoid side, if any of you guys have taken salicylic acid, that is aspirin. Plants produce this. In the flavonoid side, there's a group of wonderful compounds called oxygen reactive absorption capacity. This is your ORAC, or ORAC capacity, which is how you absorb and get rid of free radical damage, okay? And so in general, the reds, purples, blues, these are the colors in plants that are filled with these type of flavonoids. Then you have sulfonated amino acids, which are your cruciferous vegetables. These are anti-cancer, or they're liver detoxifiers. Your alliums, antibacterial, antifungal, antiviral, anti-cancer. So let's look at one group, just essential oils, all right? We have hydrocarbons and oxygenated compounds. Now, again, we're taking the secondary metabolites, we're breaking it down into different groups. Now we're looking at subgroups, and then we're going to look at more subgroups. But just in the terpenoid groups here, we've identified over 22,000 different terpenoids, and the number is climbing. In each component, each terpenoid, there's between 300 and 800 different constituents or components in each terpenoid. So you start doing the math, you have somewhere between 6 to 7 million different components to 17 million components just in one of the four groups. So when we look at the oxygenated compounds, we have esters, aldehydes, and ketones. I want to back up here and just go through these. In the hydrocarbons of essential oils, we have monoterpenes, and there's 1,000 or more of these identified, and the number's increasing. We have sesquiterpenes, 7,000 plus. Diterpenes, 3,000 plus. The sesterterpenes, now this is 5 groups and going up. Triterpenes, 6 groups and going up. Tetraterpenes, 8 and going up. And so these are increasing all the time. In our oxygenated compounds, we have esters, aldehydes, and ketones. Our esters are calming, relaxing, antifungal, antispasmodic. Our aldehydes, anti-infectious, anti-inflammatory, fever-reducing. They work on hypotension, anti-antiseptic, antimicrobial, and antifungal. Our ketones regenerate our cells. They help with formation of our tissues. All of our mucus linings, really from our esophagus all the way to the end of our colon, are part of the ketone compounds. These help with asthmas, colds, flus, coughs, and our respiratory disease. Our essential oils continue into alcohols, phenols, and oxides. They stimulate immunity. They're diuretics, antibacterial, antifungal, or antiseptic. Now we get into the phenols. These are the most powerful antibacterial, anti-infectious, antiseptic. They stimulate our nervous system and our immune system. Our oxides are anesthetic, antiseptic, and help with our respiratory systems. Now, we look at one group, the first one in our hydrocarbons of our essential oils, monoterpenes. We have apinine and bpinene. This stops the absorption of our bone material. That causes osteoporosis. It is also antibacterial for gram-positive and gram-negative microorganisms. These can be pathogenic microorganisms. Camphene, insect repellent, cholesterol reducer. Myrcene, cancer preventative, cholesterol suppressant. Limonene, cholesterol suppressant, anti-cancer, antibacterial, antifungal, antiseptic. The largest selling group of drugs in the world are statin drugs to what? Suppress cholesterol. Okay, lots of nasty side effects. Plants do this without the side effects. When you look at more monoterpenes, you have antimicrobial, antibacterial, antifungal, and the list goes on and on and on. When we get into our sesquiterpenes, again, we have all kinds of compounds regulating all kinds of systems. We have antifungal, regulate the stomatal closing and opening in our plants. We have attracts predatory insects that would take out pathogenic insects feeding on plants, stimulates insulin release in our pancreas, insecticidal, repellent. We continue on anti-potent, antibacterial, antifungal, deters insects feeding in plants. Again, plants have an immune system, but without trace elements, activating enzymes, these compounds are not being made. So again, we look at antimicrobial, antifungal, effective against the AIDS virus. Okay, we have anti-inflammatory, antispasmodic, diterpenes, retinol, vitamin A. This is where it comes from. Our phytohormone gibberellin, which regulates plant growth and germination. This is a diterpene. All right. Let's keep going on down through here. If any of you guys have tried stevia, this is a plant sweetener. It is a diterpene. Okay, your gibberellins, your gibberellic acid, stem elongation, stem growth, seed germination, fruit set and growth. This is all going on inside your plant. This is where they're found. This is where they're formed. When you look at triterpenes, steroids, okay, you have anti-inflammatory, anti-arthritic. They inhibit tumors and growth. They're anti-malarial. Then we look at the sterols, which is anti-inflammatory, antibacterial, antifungal, and it inhibits cancer development. Anti-inflammatory, autoimmune disease suppressant with cholesterol and cancer and antioxidant. Okay, we go into tetraterpenes. Okay, again, we have all of these antioxidants, anti-inflammatory, over and over and over, the production precursors to vitamin A, cancer, cardiovascular disease prevention. And you go on, we have our yellow pigments, our lutein. This is incredible for eyes. And you have astaxanthin, which is one of the most powerful antioxidants that's out there. And you go through and you look at all these anti-carcinogenic, anti-inflammatory, radical scavengers, anti-obesity. Then you get into your phenols, which are anti-inflammatory, they're immune modulators, these antioxidants. Then you pick this up and we go into the green teas, the anti-cancers. You have celery, parsley, immune system, dandelions, thyme, all of these amazing compounds. Phenols are part of the structural strength of our cell walls, our capillaries, our blood vessels, vitamin C, and again, our oxygen reactive absorption capacity. Free radical scavenger, stabilizes our cell membranes, reduces inflammation. Inflammation is the base of all of our diseases. Every disease we will have starts with inflammation. Something is there that shouldn't be there. Okay? Phenolic acid, again, salicylic acid, aspirin, and again, a whole bunch of immune responses, attacks, bacteria, fungal, viruses. The plants produce over 350 groups of phytoalexins. This is a plant's chemistry that allows it to defend itself against soil-borne and airborne pathogens. And these phytoalexins are rearranged according to the plant's needs to defend itself. Well, when a plant is susceptible to all of these environmental factors that cause disease, we are not creating these phytoalexins in our plant. The trace minerals are not there. The enzymes, that intelligence, which is there but not functioning, is not producing these compounds. And that's why you see plant disease. And it works the same in plants, it works the same in animals, it works the same in humans. So your resveratrol, a lot of noise about that lately, stops cancer, strokes, cardiovascular disease, Alzheimer's disease. Okay, so you start looking, this list goes on and on. So my question really is all of these incredible compounds that exist out there, why are we sick? We are not designed as a species to be sick. All these diseases that are taking us as a society and as a nation are not the way we're designed. We don't have the biological input or the mineral input into our plants. We kill the messenger, which is the insect or the disease. We harvest an unhealthy, unfit plant, we eat it, and then we say, gee, why are we sick? We're eating components that aren't complete. If an insect wants it, you shouldn't. And so when we look at our sulfonated amino acids, our cruciferous, our kale, turnips, cabbage, broccoli, our horseradishes, Brussels sprouts, all of these guys are producing incredible compounds, these anti-cancer, liver detoxifiers, our alliums, our garlic, onions, leeks, antibacterial, antifungal, antivirus. And this whole thing goes on and on and on. These plants can produce millions of compounds, but the biological pathway is through microbial nutrition and mineral nutrition, and God did not put plan B into place. There is no secondary plan for this to happen. So, guys, that's what we've learned from agriculture. That's what we do. Hope you enjoyed it, and we have taken up twice the time that we should. I hope it's worth your time. We love sharing it. And Jared, thank you kindly.
Hey, thank you very much, Ken. We sure appreciate you being willing to share that information. If anybody has a quick question, are you good for questions? Mike, will you go ahead and stop the recording?